In October 2017, the world of astronomy was shaken by a truly extraordinary event. Scientists detected, for the first time in recorded history, an object that had entered our solar system from the vast interstellar expanse beyond. Unlike anything previously observed, this celestial visitor did not originate from within our own solar family. The object was soon given the name Oumuamua, derived from the Hawaiian language, meaning scout or messenger sent from afar. The choice of name was fitting, for the object appeared to carry with it secrets from an unknown region of the cosmos, perhaps even a different galaxy. From the moment of its discovery, Oumuamua became a subject of intense scrutiny and fascination within the global scientific community. Its erratic path, highly elongated shape, and baffling physical characteristics defied conventional explanations and challenged the boundaries of our understanding of natural celestial bodies. As it journeyed past the sun and moved out of the solar system, astronomers and physicists found themselves captivated by what it might represent. Could it be a chunk of icy debris, a fragment of a shattered planet? Or, as some speculated with excitement and controversy, could it be an artifact of intelligent design? Adding to the mystery, Oumuamua exhibited behaviors that could not be easily explained. Unlike typical comets, it had no visible tail or coma, those luminous clouds of gas and dust that are formed when comets approach the sun. There were no signs of outgassing, no jets of vapor or particles being expelled. And yet, it appeared to accelerate as it left the inner solar system, moving faster than gravity alone should have allowed. This peculiar acceleration did not fit neatly into any known model, prompting a wide array of hypotheses, ranging from the mundane to the truly extraordinary. For years, astronomers debated its origin, structure, and possible mission. Some researchers suggested it could be made of a special type of hydrogen ice that evaporates invisibly. Others proposed it might be a fragment of an exotic exoplanetary object, possibly one that had been flung into interstellar space after a gravitational cataclysm. And still, there were voices, including respected scientists, who entertained the possibility that Oumuamua might be an alien probe, an interstellar device sent, perhaps intentionally, across the cosmos. Until recently, however, these ideas remained speculative due to the limited observational data available. That changed with the advent of the James Webb Space Telescope JWST, humanity's most advanced eye in space. Launched in December 2021, JWST was designed to look farther and deeper into the universe than any telescope before it. Unlike its predecessors, it operates primarily in the infrared spectrum, allowing it to detect heat and faint signals from cold, distant objects that would be invisible to other instruments. When scientists finally turned JWST's powerful instruments toward the now distant Oumuamua, the data that came back was nothing short of extraordinary. For the first time, we obtained a true image, albeit distant and grainy, of the object. It confirmed several long-held assumptions while also revealing new surprises. The shape of Oumuamua is indeed highly elongated, resembling a flattened cigar or pancake, unlike anything typically found among asteroids or comets in our own solar system. Its surface is irregular, marred by ridges, craters, and ancient scars, evidence of eons spent drifting through the harsh, radiation-filled vacuum between the stars. But perhaps the most groundbreaking revelation came from the analysis of Oumuamua's composition. The surface was found to contain a complex mixture of organic molecules and rare elements, compounds that do not typically form in the environments found within our solar system. These substances suggest that Oumuamua originated in a chemically rich and diverse region, possibly near a young and dynamically active star system where conditions for exotic matter formation might exist. The presence of certain reflective compounds also helped explain its unusual brightness as seen from Earth. One of the enduring puzzles, its acceleration remained unsolved by traditional means. JWST ruled out the release of gas or ice as the cause, which would normally account for changes in a comet's speed. Instead, a more exotic theory has gained traction. The idea that Oumuamua could be propelled by a light sail, a hypothetical spacecraft propulsion system that uses the momentum of photons from a star to travel vast distances. While still theoretical, the possibility of such a technology has been seriously explored by institutions like the Breakthrough Initiative, and Oumuamua's behavior appears to align with some of the expected dynamics of such a system. JUICE. Detailed spectroscopy allowed scientists to examine the light reflected from Oumuamua, unlocking even deeper secrets. The data showed a mix of metallic elements and minerals not found in typical solar system bodies. Among these were compounds that can give rise to organic molecules, the fundamental building blocks of life. The implications are profound. Oumuamua might be part of a larger process in the universe whereby organic matter is transported across light years, seeding planets with the potential ingredients for life. This notion, known as panspermia, has been a subject of scientific speculation for decades. If Oumuamua is part of such a process, it would be the first concrete evidence supporting the idea that life's ingredients can be spread from one star system to another, adding yet another layer of intrigue. A recent theory suggests that Oumuamua could be a remnant of a destroyed planet. According to this idea, powerful gravitational forces, perhaps from a supermassive star or a nearby black hole or a planet apart, flinging pieces of it into the interstellar void. Oumuamua, with its strange shape and peculiar material makeup, could be one of those fragments. If true, it means the object is a survivor of a violent cosmic event, silently carrying the geological history of a long-lost world across the galaxy. The study of such interstellar objects doesn't just provide insight into their own origins. It opens a window into the processes that shape planetary systems far beyond our own. Each molecule, crater, and glint of light from Oumuamua tells a story not just of itself, but of the chaotic, creative, and destructive forces that define the cosmos. It invites us to consider how many other Oumuamuas might be silently traversing the galaxy, unnoticed in the blackness of space, carrying the signatures of alien worlds. Oumuamua's unexpected appearance has reshaped the goals of astronomy and space exploration. It has inspired a new generation of scientists, engineers, and dreamers to consider missions beyond the solar system. Initiatives like Breakthrough Starshot, which aims to launch ultra-fast probes toward nearby stars, may one day intercept objects like Oumuamua, enabling us to study them up close and perhaps even capture samples. These missions represent a new frontier, one in which humanity doesn't just observe the universe from afar, but actively engages with it. This celestial messenger has done more than challenge our understanding of physics. It has forced us to question the very nature of life, existence, and our place in the grand cosmic tapestry. Could our own origins be linked to interstellar wanderers like Oumuamua? Is it possible that Earth, too, was once seeded by a passing traveler bearing the essential components of life? Far from being just a strange object in the sky, Oumuamua is a cosmic time capsule. It is a physical remnant of a universe that existed billions of years ago, containing within it the echoes of forgotten systems, ancient stars, and cataclysmic events. Its journey is a quiet but powerful reminder that the universe is in constant motion, that its history is written in the motion of rocks and dust and light across unimaginable distances. Thanks to the James Webb Space Telescope, we have taken a meaningful step forward in unlocking these cosmic secrets. The image and data from Oumuamua have already transformed our understanding of what lies beyond, and yet they only scratch the surface. The universe is vast, mysterious, and filled with phenomena we have yet to encounter. Oumuamua is not the end of this story. It is only the beginning. We now live in an era where the boundaries of science are expanding faster than ever. Each interstellar visitor offers us a rare opportunity to learn not just about distant regions of space, but about ourselves. Where did we come from? What forces shaped our planet, our solar system, our galaxy? And could other intelligent civilizations be reaching out as we begin to explore further into the stars? Oumuamua may be silent, but its message is loud and clear. The universe is alive with possibilities. As we continue to explore, we are reminded that our curiosity is one of the most powerful forces we possess, no matter how small we may seem. In the cosmic scale, our drive to understand makes us limitless. So what do you think Oumuamua truly represents? Could it be nature's messenger or something more? Share your thoughts, join the conversation, and continue the journey of discovery. With us, the cosmos has much more to reveal, and Oumuamua is just the first whisper in a much larger conversation waiting to unfold.